Another important thing to talk about is what we call conditional probability. So to understand this, let's review what we mean by independence. Two events are independent if knowing the outcome of one has no effect on the probability of another. And this gave us this rule that we've used many times, that for independent events, the probability of A and B, which we've used a lot for sequences, is the probability of A times the probability of B. We just multiply them together. However, if A and B are not independent, then knowing if A happens does change the probability of B. And so we have a special notation for that. We use this P parentheses B vertical stroke A. The vertical stroke is on the keyboard above the enter sign, but it often doesn't really look like a vertical stroke. So you think about that as the probability of B happening if A has already happened. Like, you know A has happened, what's the probability of B after that? And when you see this notation, it generally means that, knowing whether A happens changes the probability of B. But it doesn't really change our multiplication a lot. We just need to take it into account. So in general, the probability of A and B, whether you're dealing with something which is explicitly an and statement, or maybe it's just another sequence, you still multiply, and you start with A, probability of A, just put that in as usual, and then you'll move on to multiply by the probability of B, but you have to take into account that A has happened. So there are a lot of situations that involve conditional probability. A lot of things don't. We've seen a lot of things so far, like random numbers generated by video games, rolling dice, flipping coins. Those are all, you can assume they're independent because each time the process just starts anew with no memory of what's happened before. The one we saw which does involve conditional probability is drawing without replacement. And this should make sense because once you take a marble out of that bag, there's fewer marbles left in the bag. So knowing you drew a red marble first does change the probability associated with the next marble you draw, and so on after that. A giant earthquake and my untimely demise would definitely be two events that are not independent. Because if a giant earthquake happens in the Pacific Northwest, which some people say is overdue, I am much more likely to die than I am just overall. And you could represent that with this notation. The probability I die if there's a giant earthquake is much bigger than the probability I die in general. And really, whenever two variables are correlated, they are not independent, whether you use correlated in the strict statistics term or just whether any two things go together. But you see a lot of conditional statements, like just when you're reading, but you tend to overlook them because they're just such a normal part of English, you don't really think about relating them to math class. So you might see statements like, of those who responded positively, 46% indicated. So that's a probability is 46% if, or given, that someone responded positively. In the next video, we'll look at several examples and calculations using conditional probability.